So instead of an equal sign, this unit is about quadratic inequalities. And so what's happening to our equation that we had before, which was equal to 0, now we're going to solve equations that either have less than or equal, less than, greater than or equal, or greater than. And it combines our idea of graphing and solving together. So if I look at 5x squared minus 13x minus 6, which we had solved before, okay? Well, they've got their own example. We'll look at the example that they have so it matches with your note. If you take x squared minus 2x minus 3, if you made it equal to 0, x squared minus 2x minus 3 equal to 0, that would be one that factors nicely. X and x minus 3 and plus 1 equals 0. You would get x equals 3 and x equals negative 1 as our answer. And factoring would probably be the easiest way to solve for that one. If you graphed y equals x squared minus 2x minus 3, you could either change it to vertex form, okay? By completing the square, I'm just going to do it quickly for you. So if you completed the square and changed it to vertex form, you would get y equals x minus 1 squared minus 4. Can you see that that would be a parabola with a vertex at minus 1 minus 4? It would go over 1, over 1, up 3, just like our graphing unit. And in particular, we have x-intercepts at 3 and negative 1. And so in this unit, we start to look at where is it that if we had x squared minus 2x minus 3, where is it bigger than 0? So I'd like you to guess and check, and I'd like you to find one value that you could plug in for x, where it's bigger than 0, and tell me one value that you plug in for x that it's not bigger than 0. Tell me something that works and something that doesn't work. Okay. And Yaniv's going to pick our first volunteer. Pick a volunteer. They're going to tell me, we're looking now at x squared minus 2x minus 3. We want it to be bigger than 0. You pick someone to tell a value. Nick, what's the value you're going to check?
For the bigger one?
Well, we're going to find out if it works or if it doesn't work.
Negative 4, I guess.
He's going to try negative 4. So if you plug in negative 4 in for x, would you agree if I wrote it out, it would be negative 4 squared minus 2 times negative 4 minus 3. And we're wondering, does it make it true? Is it bigger than 0 or less than 0? Well, if I square negative 4, I'm going to get 16. And this is going to be plus 8 minus 3, which is going to be equal to 21. Is that bigger than 0? Yes. So we're going to say that minus 4 is part of the solution. The question is minus 4 the only number that works? Does minus 2 work? Yes, minus 2 works as well. Are there any numbers that don't work? 1? So let's see what happens when we plug in 1. If I plug in 1, I would get 1 squared minus 2 times 1 minus 3. Is that bigger than 0? Well, this would be 1 minus 2, negative 1, minus another 3. That would be negative 4. Is that bigger than 0? No. So 1 doesn't work. Negative 4 worked. Negative 2 works. 2 doesn't work. Negative 3 works. 0.5 doesn't work. Negative 0.5 doesn't work. Negative 5 works. So how do I do this so quick in my head? How am I calculating everything out? No. How do I know what works and what doesn't work? Positive numbers or decimals won't work. Well, actually, if I choose 8, it will work. If I choose 3, it will, no, 4 will work though. 3.1 works. Why? Anything from 3 to negative 1 don't work is what Jesse's saying. Why do you think that? 3 makes it 0. That's right here. Negative 1 makes it 0. And we're looking for the places where it goes bigger than 0. And the answer is in our graph. Because the answer is like the y values. Where are the y values bigger than 0? Can you see here my y values are bigger than 0? And here my y values are bigger than 0. So I could say, when you said negative 3, I went up to my graph and said, ooh, my y value would be bigger than 0 when x is negative 3. And when you said positive 4, I'd say, yes, my y values are bigger than 0 at positive 4. But anything between negative 1 and 3, you can just put it at the bottom of the pile. Can you see that your entire graph is below there? So there's going to be 2 ways that we're going to solve these equations. Okay? One way, well, both ways we're going to find out first, when is it equal to 0? So we find it by factoring or use quadratic formula. We're going to use chapter 3 to find out where it's equal to 0. And then we're going to look at either the graph. And when I look at the graph, this question was saying, when is it bigger than 0? And so I look on my graph and I say, when are my y values positive? Because then the answers would be bigger than 0. And so my solution, and we're going to learn some crazy ways to write the solution. The solution to this one looks like this. We could either say x is less than negative 1 or x is bigger than 3. That's one way to write the solution. The other way to write the solution is to write an interval. How do we write x is less than negative 1? Well, we start at negative infinity and we go up to negative 1. How do we write x is bigger than 3? We start as 3 and go forever to infinity. If we use this notation, they have a special symbol for or. It's a big U. So we're going to learn that that's the solution. Now the textbook says if we highlight those parts and then visualize a big light shining from above, it would make a shadow on the x-axis all the way this way forever, and it would make a shadow on the x-axis all the way that way forever. Does that visual make sense to you? Me personally, once I've highlighted the part that's going up, I just think that if you go down, whatever x values are to the left of that point will have a point that the y value is positive. Whatever x values are here would have a point where the y values are positive. That's how I sort of think about it. Okay? Another method for finding out where something is true or not is with a truth table. And this comes up a fair bit once you take calculus in grade 12, so it's a nice technique to learn. You find out where it's equal to 0. It's equal to 0 at -1 and at 3. Those were the values that were equal to 0. And then you test 1 point in each section. So can you see we already tested -4? And -4 came out to 21. We ask ourselves, is 21 bigger than 0? Because that's what the question originally was, bigger than 0. The answer is yes. So this whole section is true. And that's how we would write x is less than or equal to or less than -1. What about a number between -1 and 3? What value would you like to try? Well, we tried 1. When we plugged in 1, we get -4. Is -4 bigger than 0? No. This whole section is false. And if you try a number bigger than 3, like 5 or 6 or 7, it comes out true again, so we would be able to say that this section is true. And then your answer from this diagram says x is less than -1 and x is greater than 3. Okay? Now these values where it's equal to 0, they have in your notes, they call them critical values. So I'm going to highlight that in your notes. Because that's where things change from being positive or negative. Oh, they did another example and said, where is it less than 0? Can you see that that would be that section, the opposite of the other section, where the graph is below? One of the things we're going to decipher on our true and false line is that when the sign is less than or greater than without the equal sign, at our key points, which are critical values, you'll notice they put open circles there. Technically, if I go back to the example that we did when showing you at first, I should have gone at -1 and drawn an open circle, and at 3 and drawn an open circle to say they can't be included. Those are the values where it's equal to 0, and I'm just looking for the values where it's bigger than 0. So we find our critical values, and they just shade it, but I always put the fact this section in this case would be true, and these sections would be false. So if you want to highlight the part about the open circles, the open circles say that those are not part of the solution. So with this symbol or this symbol, you will use open circles. With this symbol or this symbol, we'll draw closed circles. So to summarize, and you probably have room at the top of page 341 in the column. How to solve a quadratic inequality is a lot like solving a quadratic equation. Step 1, we make one side equal to 0. Step 2, You solve it like a normal quadratic equation. Wow, I can't spell today. Which means factoring or quadratic formula or the completing the square, etc. Draw a number line with those critical points. And then either use your graph or test points to find which intervals are true or false. And once you find out where they're true and false, then you can write the solution. So we'll do example 1. Move too fast. There we go. Here's example 1. Solve this quadratic equality. Represent the solution on a number line. So step 1, we move the 1 over to the other side, so one side is equal to 0. We can make a little note. The next thing we want to find are the critical points. The critical points are when this is equal to 0. Most likely factoring will be the fastest. So to get 3x squared has to be 3x and x. To get 1 will have to be 1 and 1. Outside will be plus, inside will be minus. And so we get our solutions are x equals 1/3 and x equals -1. After we found our critical points, we draw our number line with our critical points. So -1 would be on this side, 1/3 would be on this side. Since it's less than 0 without an equal sign, these will be open circles. Draw them in blue. And then we either have to use test points or the graph to figure out which sections are true and which sections are false. If we're using the graph, with the graph, all you need to do is label your x-intercepts, which you already figured out. One of them is at -1/3. Sorry, one of them is at -1. And one of them is at 1/3, right there and there. If you were graphing this parabola, would it open up or would it open down? It would open up. So this is as accurate as your graph needs to be. Just a quick sketch, having it open the correct way. We want to find out when it's less than 0. In other words, on my graph, when are my y values negative? Can you see that the middle section is where the y values are negative? And so you could do, I know this is true, I know these are false. That's using the graph. Using a test point, you would have to plug in something between -1 and 1/3. I would choose 0. Still 4 minutes left. And so if I plug in 0, can you see that you get -1? Is -1 less than 0? Yes, that's why that section is true. If I plug in a number bigger than 1/3, if I plug in 5, I might even use the factored part. Here I'm going to get 15 minus 1. Here I'm going to get 5 plus 1. 6 times 14. Both are positive numbers. Is it going to be less than 0? No. So I can use test points as well to find out the true, false, and true. And finally, you need to write your solution. So your solution for this one is between -1 and 3. So you can either, oh, it won't have an equal sign. You can either write it as inequalities, 1/3, thank you, between -1 and 1/3. There wouldn't be equal signs here because we have open circles. Or you could write it in interval notation, and we would use round brackets to show that the points aren't included. To indicate our graph on the solution, you just shade the part where it's true. No, you can choose either of those two ways to write it. Okay, questions for practice are 4, 5, and 6.